Hi, my name's John Capobianco, and what I thought I would do is address the number one thing that's coming at me is how do we build these AI agents? How are they built? Without having to comb through some of my older videos. Because I've been building agents for a few weeks now, maybe even to the months. They're very exciting, and I want to highlight a few things. Number one, we do need to use ChatGPT for this, meaning you're going to need an API key from ChatGPT. We're going to be using the ChatGPT 4.0 model. It seems to do the best chain of thought and tool calling. So a ReACT agent, reasoning and action. And I'm going to get into that a little bit more. You can try this with a tool called OLlama, and I would recommend that you use the Llama 3.1 model, and I also recommend the Cohere Command 7RB model. You might have some success with those. For the ease of this video, I'm just going to be using the ChatGPT model. So we're going to be using some space APIs because they're open and free, and I think they're interesting, and we're going to do some unique things with them to make AI agents, ReACT agents. Having some Python code experience is recommended. However, I think that writing AI agents is the best place to start learning Python if you're not already writing Python. Network automation is where I started writing Python code, but if AI agents, if you want to catch this wave of innovation, you are going to have to know a little bit of Python, but that's okay. We're going to cover some of that today. The other thing I want to point out is that I have a canned agent that works, and I'm also going to add an agent sort of dynamically. And I'll show you what I mean by that. We're going to add a second agent. The other thing is that we're going to have a parent agent, a main agent. So I don't think an individual agent on its own is, it's exciting, but it's not as valuable as writing smaller purpose-driven agents that can interact with each other. They're going to have their own tools, but we're going to make a few different agents that can interact and work with each other. So we're going to be doing that with a tool called LangChain, a framework. And I'm just grabbing some different LangChain documentations before I switch over to the screen. Give me 1 second. And okay, so let's get into the live portion of this how-to guide. You're going to need a few tools. If you have Git experience, you can Git clone this repository and literally follow the code. I'll be putting the link to the code and showing you how to use it with Git at the end of the video. VS Code is my recommended integrated development environment, IDE. So grab VS Code and use that, like I'm going to be doing in the video. I'm also going to be using Docker, and I don't want you to be scared. I'm actually going to show you in some housekeeping how to build a Docker container for your agents, your agentic system. And I do that for a few reasons. I don't want to have to explain Python virtual environments or use a package installer to install a bunch of packages in a virtual environment. There's a bit of friction there. Docker lets me abstract that to another layer where you can run the Docker container and not have to worry about installing anything. Just start running the code. So let's get going. So the first thing we're going to look at is a quick Excalidraw. What we're going to use first is the International Space Station REST API. All right, that's up in the cloud. But like I said, we're going to put a main agent, and this is also going to be our Streamlit front end, and I'll show you what that I mean by Streamlit. Let me get that open in another tab here. So Streamlit is a faster way to build apps and share data apps, and I use this for all of my Python front ends, and you can see it ties in nicely with things like LangChain. Okay, so it's a nice seamless integration that I use for my front end. All right, so that's going to be a combination of my main route, and this actually acts as a router. in networking terms. It's going to decide when to send data or receive data from the ISS. We're going to come back to this drawing in a bit. But in terms of the tools we're going to be using, first is the International Space Station Current Location API. It moves close to 28,000 kilometers an hour, so its location changes really fast. Where is it right now? And you can see there is this API that we can click on, and we're going to get the JSON value of where the ISS is. Can we make a simple AI agent to do this for us based on natural language query? I'm going to be using LangChain for this. In particular, I'm going to be using their prompt templates, and I'm also going to be using their agent executor. I urge you to look into these. The other thing is, we're going to be using, I missed it, I already have it open here. This approach, the ReACT agent model, and I do want to call out this paper. I'm not claiming to have invented this, but I've pretty much figured out how to do this repeatedly using the question, thought, action, observation approach and some of my own twists. And you can see some of the, some of their response rates and some of the different agent types and stuff. A very worthwhile read. So before we get to the code, let me show you what I've done. So chat with Space Ace, ask real-time questions about the International Space Station. And we're going to adjust this because we're going to do more than just the space station. And I asked, where's the ISS right now? And it went ahead and agentically found the answer. And we have the conversation history here. So how is this built? It's actually built with a couple of files. One for the agent itself, for the ISS locator, and one called Space Ace for the main front end. All right, now each of these files is only is about 100 lines of code, but I'm getting ahead of myself. Let's do the housekeeping. So I'm using a Docker Compose file that will bring this up on 8501, the port, my Streamlit application for this container. Okay, so this is the Docker Compose, and we're going to literally say Docker Compose up. And I've added -- build because as I'm adding code, we want it to rebuild. But you're just going to say Docker Compose up when you clone the repository yourself to bring all of this up. Before you do that, you're going to need a .env file with the OpenAI API Key from ChatGPT, okay? Add that file and then bring the container up and you should be good to go. Now, what is the Docker made of? It's made of a Docker file, which has its own syntax, and this is from Ubuntu. So this is a Linux operating system inside of this container that I'm updating and installing some tools. I'm installing Python. We actually don't need this SSH client, so I'm going to delete that. And we're installing the LangChain community, LangChain OpenAI, and Streamlit packages, and an OpenAI package. I'm copying in my Python code files and a little file called scripts that I'm using to start up the system. And this little script is just a bash script that does the Streamlit run Space Ace Pi. Okay, so that's the housekeeping. That's how all this is built and put together. We're going to first look at the actual ISS locator agent. Okay, now this is going to be a .py file, and we're going to go over it a little bit step by step. So a couple of tools that need to be imported. I'm bringing in operating system so that I can load the environment variable using the load.env package. So all of this is just related to handling my OpenAI key. I have some logging, and I've set the ISS API URL from that JSON file in the cloud for free. Now, in terms of the LangChain, I'm bringing in 4 different packages. I'm bringing in their tools, tool, OpenAI, chat OpenAI, agents, the agent executor, and the create ReACT agent, prompts, a prompt template. And you're going to see how I instantiate a tool, use ChatGPT, create and execute an agent, and have a prompt template. Now, I guess I could put these in the order that I call them. But, so I make a little ISS locator class. Let me minimize these so it's a little bit easier to go through. All right, so here we go. So I have a class for my ISS locator that initializes with the URL and fetches the ISS current location. Right, I have a function called getLocation, and I go ahead and get that JSON and return the data. I define ISS location, where I'm going to initialize that locator and run that class. And then I define a tool. Remember, we imported the tool? Well, this is the LangChain tool. The name, the description, and the function is get the ISS location, which we defined here, which instantiates this class up above. Right? Pretty simple stuff. We're only 50 lines in so far. LLM here is the ChatGPT with a very low temperature because we want this to be precise. We don't want it to guess. And let me just break this code up a little bit. We're going to define our tools, and in this case we have the one tool. Our tool names, which is the description, or the name of the tool, and then the tool descriptions. And we only have the one tool. The next is going to be the prompt template. And if you look here, we jump from line 66 to line 94. So 30 lines of this is not even code. It's a template. So we're going to take some input variables of input and a scratch pad for the agent. And here's our template. You are an International Space Station tracking agent. Your job is to provide the current location of the ISS when asked. The format, thought, your reasoning, action, that location tool. There's no input, right? We don't need to pass the tool anything. Go ahead and get the result as your observation and make a final answer to the user. And here's sort of an example query to give it a bit of guardrails. We begin with our question input and our agent scratchpad. Finally, we define an agent with the create ReACT agent passing it the LLM, the tools we've defined, and the prompt, passing in the tool names and the tool descriptions. Okay? Next, we have an agent executor, where we pass it that agent we just created, the tools. I like to handle parsing errors and a verbosity of true. The max iterations is 5, shouldn't need to run more than 5 times, and a max execution time of 30 seconds. This should be a real quick API call. I'm going to do some logging, and then I'm going to set up a little class here, as an example execution. So that is the ISS locator, about 100 lines of code as the agent. That agent's job is to get the location of the ISS. Now my front end, I'm bringing in tool and an initialize agent, and I'm bringing in Streamlit for my UI. The other important thing is, from my ISS locator, I'm bringing in the tools and the prompt. Okay? So, again, the OpenAI key, some basic logging, I define my LLM. I'm going to initialize an agent as a zero-shot ReACT description, passing in the tools, passing in the LLM, passing in the agent and the prompt with some verbosity. All right? I define this as a function. I set it up as a tool. I have my parent tools, the ISS tool, and I'm going to initialize that agent, parent agent. So now this agent has been initialized, and we're ready to go with the Streamlit front end information, how we ask the questions and everything. So I hope that's all very clear. Let's go ahead and bring this up. And it's sorry for the hiccup there. There was a slight build problem, but we've built it now, and you can see that the main parent routing agent initialized with the ISS locator tool. All right, so the main agent is ready to go and been initialized with that tool, the sub agent. There's a deprecation warning here. I'll get to that in due time, but I can click on this link and it will take me to the Space Ace. All right, so let's see here and say, where is the ISS right now? And we're gonna send that. And we can watch that it's gonna go ahead and call the agents and the tools. We have some connection timeouts here. Let's just give it a second. Okay, there we go. So the ISS is currently located at latitude and longitude. Pretty cool. Now I did have a couple timeouts, but I built in a timer there to retry it after 5 seconds. I'm not sure if it knows that it's a bot, so it's slow, but anyhow, it does work. So what can we do now? What are the other space ones? Well, there is also a how many people are in space right now API at Astros. And it gives the name of all the people in space and what spacecraft they're on. So in the spirit of the drawing here, what I thought we could do is see if we could get them to interact. Right? So what we could do is make another agent, right, called astronauts, let's just say Astros in space, and it is the REST API. All right, now we're gonna do the same thing and see if we can get the router agent to pick up this new agent we're going to write, okay? So we're gonna start here with the 2 agents. Now they won't interact with each other, they will route through this agent. So we might be able to say, who is on the ISS and where are they above the Earth or something like that, right? To combine and see if we can get interaction between the 2 agents. So I really am literally going to copy the first agent and we're going to do this live. So let's bring this system down and we're going to go in here and we're going to copy the ISS locator and we're going to rename this Astros. Okay, so we just need to change the URL to the astronauts in space URL here. We're not going to change too much. We're going to rename this class Astros. And this is the Astros API URL. All right, and we're going to say get Astros. Fetches the current people in space and what spacecraft they are on. And we'll leave that with retries. So we're going to do a loop here and retry and add some timeout values just to be safe, right? This is a little bit more advanced Python, but it's just a safer way to get the JSON and to retry if it does timeout on us. And we're going to fail to fetch Astros after multiple attempts. So the next one here is going to be the get Astros. Fetching the humans in space and their spacecraft. And we're going to now call that class, our Astros class, here. Okay, and then we're going to make the tool, right? And this is going to be the get Astros tool. Astros, be careful here. Get Astros tool. Fetch the current humans in space and the spacecraft they are on. And our function here is going to be the get Astros function. Calling our LLM. We're going to update our tool list. And now we can update this here. You are tracking the astronauts in space along with the spacecraft they are on. Your job is to provide the information about the humans in space. Okay? And our reasoning and action here, the tool we want them to call is the Get Astronauts tool. How about who is in space right now? I need to find who is in space. I'm going to use that tool. And our observation here is going to be, let me grab an actual, how about like just that guy's name? The final answer is in space right now. Okay. Now the rest of this, I don't think I even need to change. We don't need to touch any of this except for our initialization here. Astros in space agent initialized. And just a quick little function here. Who is in space right now? Okay. So now we have to incorporate this into the main agent. And I'm just hoping that, that it's not hallucinating. That it's actually calling the right location. So we should validate that. But anyway, because I didn't see this flag here come up, this in our logging, I'll have to look closer in the logging to see if the Astros in space agent is actually being initialized. So let's go to our space ace, and we're just going to do, we're going to import, and this is from Astros. Did I rename the tools? Yeah, I gotta rechange this prompt to Astros prompt. And Astros tool and Astros prompt. Okay. The next thing we're going to do is initialize an agent. And we'll comment this, initialize the Astros in space agent. And this is the Astros tool and the Astros prompt. We're going to define a function for Astros. And this is going to be Astros input text. We're going to make the LangChain tool for the astronauts. Name astronauts in space. Use this information to retrieve information about the humans in space and their spacecraft. Now we just have to add this tool and rename it to Astros tool here. And that is it. And we're going to change this about space instead of astronauts in space. All right, everything else should remain unchanged. So you see what we've done here. We made a new astronauts agent, and then we tied it into the space agent. Now I am going to pause really quickly, not because I don't want to do this live, but I just want to make sure that the space ace is actually invoking the subagents based on that logging. If I make any adjustments to the code, I will show you. I'll be right back. Yeah, sorry, there was nothing to panic about. It's right here. I was looking below the deprecation warning. It actually initializes the subagents first, which is pretty cool. And now, check it out. We have an Astros and Space agent initialized. So our front end's ready for a question. Let's see if we can get all three to play together. So we're going to say, where is the ISS and who is on board right now? Send. So now we're actually going to see it interact hopefully with both agents and tell us who is on board and where it is. Now, it's unfortunate that I'm not getting the reasoning in the logging. I'm going to maybe try to pump up my logging a bit so I can see the reasoning. But here we go. There's this location, and here's the astronauts currently on board. Very cool, right? So we can just keep building and building with more and more agents. I've been thinking about a couple of agents, like maybe something, since we have this detail, what can we do with latitude and longitude? Is there an Earth API that I could find out where that is? Or could I ask ChatGPT where that is naturally? Maybe a weather API, maybe a Wikipedia API, and I could look up the people. Let's just try one more time and just say who is in space right now, and just make sure that our Astros agent can grab the Chinese agents as well. Yeah, so on the Tiangong space station. Very cool, very fast. So, because some of those other services require APIs, API keys, I should say, I'm going to stop right here. This is a good place to make a pause, to take a break, to recap, maybe watch it again, clone the repository in GitHub, and take a look at the code so far. I'm sure you could do this. We've added an agent on the fly. I'm going to go ahead and maybe see if we could add a weather system or Wikipedia or some other agents to this little space agent to build it out a bit more. I'm also going to look into the NASA APIs. I know they have a ton of APIs for NASA. But for now, I'm going to stop right here. And it's a good place to take a break. I'm going to be doing some more research into space APIs. And I'll follow up this video with a part 2. So here's what I'm going to do before I move on to a part 2. What we're going to do is I'm going to commit this code into GitHub. Okay, so I have my Docker file, my Docker Compose, my Docker file, a startup bash script, a git ignore to protect my environment file that you need to set up locally with your ChatGPT API key, an Astros file that we built together, copied from the ISS location agent, and the front end Space Ace agent. We're going to commit this in as initial commit, and I'm going to push this code up into GitHub. Now, where you can find this code and how you can use this code, and I'm going to stop it and shut it down gracefully here. If you visit my GitHub, which is github.com/automateyournetwork, and go to repositories, there is Space Ace. Now, I don't have a README yet. I will flesh out a README, but this video acts as the README. So what you need to do is hit code, copy this link in, and then do a git clone locally to copy the file system down locally. From there, you can use the Docker Compose up after you add a .env file to this folder here, the Space Ace folder. So I'm going to be hunting down some more APIs. And in the meantime, you can catch up to where I am here. I'll follow up with a part 2 later. This was how to build an AI agent from scratch using space APIs. Thank you.